I see. Hey, Noni Pittenger, it's Gareth McGlynn here from the Preconstruction Podcast. Welcome on board.
Hi, Gareth. Thanks for having me.
Yeah, thank you very much. And thanks for being so flexible. It's what time? 10 a.m. PST in LA?
9 a.m.
9 a.m. Wow. Thanks for making yourself available. So yeah, I just wanted to quickly bring you back, Noni. Well, first of all, before we go back to 2006, give us a quick overview of what you're doing now without getting too technical, just so that people that don't know you get an understanding of what you do.
I work in technical project coordination for digital tools that approach the physical world in construction and design.
Excellent. And now we're going to jump back to 2006. Environmental planning. Talk me through maybe the time before that. Were you always destined for this world, or what was the plans?
I think it's been a bit of a journey to get here, but basically I grew up in Seattle area and was kind of in a bubble within a bubble in the 90s and early aughts. So I went to university at Western Washington University up north, and environmental studies and policy was kind of like a middle ground area of study for people from the Northwest, like just a very progressive, like environmentally focused world at that time. So also my priorities in undergraduate during my undergraduate year were skiing and being on the ocean and
nice
riding bikes. So that was a great environment for both things, like kind of premier program and then a lot of access to the outdoors. So, but I really loved environmental policy and planning because it was technical in terms of policy and it was international. So you could kind of see how different companies' virtues or values started to orchestrate like what their long-term planning for the environment was. And then I really liked getting into more of the kind of capital economics of that, like privatization of policy work versus public and nonprofit work. And from there, ironically, when you study this, when you're in environmental policy and planning, your main job prospects upon graduation are working for an oil or natural resource extraction company, manipulating the way that they store their trash. So that was a big wake-up call. And I basically kind of veered towards public policy implementation in the Forest Service because the one thing I knew was that being outside made it all a lot more relevant to me. And I was in my early 20s and had too much energy. And so I worked with the Forest Service in different versions or different roles for a couple of years, ending, kind of culminating in being a wilderness ranger in Jackson, Wyoming, which is in the Bridger-Teton National Forest, which is a pretty big program there.
Nice.
So that was that, and ultimately, federal positions for me they're very bureaucratic, they're very slow. There's policy or process improvement happens at like a federal, like executive level. So I found it wasn't a good match for the type of work and problem solving that I wanted to do. So, so from there, I started looking at, I was just doing a bunch of reading about kind of like community design solutions. And I read some article that like, just like one article where every single person referenced in the article was, quote, used to be an architect for fill in the blank firm. And so from that one magazine article, I started having the idea of, or recognized that people who studied architecture or had practiced did not want to be architects, but had really amazing problem solving abilities, and they had the tools to approach lots of different problems. So I started looking at MArch programs and kind of followed that track.
Very good. I like the pivot. I mean, one article, okay, but it sounded as if you were always going to be a problem solver, no matter what you went into. Construction, architecture, was it literally there and then, or did you do a little bit more of a dive into it and say, yeah, I wanted to drive past a major building, a landmark building, and go, I had something to do with that?
No, definitely. I was not like a armchair student of architecture at all. I've always loved doing kind of hands-on manual projects, like pretty creative as a kid growing up, lots and lots of support for that from my family. And basically I I went to an MArch program pretty blindly. And also I was living in a small town. I was like ready to move on and get a different life, and like be back in California in a city. So I kind of went blindly and immediately just found a really good fit with studio culture and with model, like kind of the bending spoons you have to do to take either like sections and 2D plans and turn it into something 3D, especially when you get into kind of irregular form languages. And that, to me, either manual or digital fabrication started immediately was like the draw for me. And I still am a terrible student of architecture. I'm not good at architectural history or art history. I rely on all of my friends in the field to educate me.
Very good.
But I really focused on studio and fabrication, and so right away I was hooked.
That's what I was going to say. Did that just catch you right away? Was that during your master's that you said, you know what? And listen, everybody finds their niche somewhere. Everyone gets their specialism. Did you get it very early on, or did you kind of like other parts of architecture?
I think I would not have recognized that was going to be, I didn't understand enough about the profession or the broader field to understand that could be a specialty. It took me a really long time to understand that could actually be an area of focus professionally. But no, I just loved it and I didn't doubt it. And it was the thing that I definitely like terrible at analyzing architectural position papers from different like just uninterested in the philosophy around it, and really driven by the physical realities of building things, especially when it came to digital tools where it was supposed to be perfect, and why wasn't it working out, and what were the tolerance issues, and how to manipulate the materials to better address that.
Yeah, very good. And then obviously qualified 2015. Where did you go from there? Did you do an internship during your master's? Were you working during your master's?
Yeah, so I worked at Testa Weiser's office at Devin Weiser and Peter Testa so I started my master's in San Diego at an accredited school that honestly was abysmal, and then from there had an instructor mentor that kind of shepherded me towards better school. So I went to SciArc and basically started over again after a full year, and it was great because I got to hit the ground running. And SciArc is a place that at the time under Eric Cohen Moss was incredibly building focused and had a lot to do with digital fabrication, and a lot of the instructor offices there were really focused on whether it was pavilion architecture or actual construction administration. There was a lot to learn there. Mm-hmm. That said, SciArc's a weird place. So basically I found a good home in Testa Weiser, and I worked for them during the school year, and then when I did have summers off, which was like 2 summers during the 4+ years I was in grad school, I would go back to Wyoming and work for, there's this high-end luxury residential firm there because Jackson Hole is a playground for the hyper wealthy. Yeah. So I got to know a lot about interior design, high detail assemblies, kind of like window systems, all the traditional architectural things. And it was really interesting. It also, the entire time I didn't feel like, I felt like I would have had to compromise what I loved working on a lot to follow the regular architectural step, like approaching licensure just seemed irrelevant to me.
Yeah. Okay. Good. And then where did the robotics or the aerospace start coming into it or developing?
So at Testa Weiser, the Testa Weiser studios that I was in, a lot of them, I'd say the electives that they taught were all in the SciArc Robotic House. Okay. Robot House. So had exposure to it there. But it was kind of a stand to the way that I interpreted it there was more like robots as a means for architectural representation using digital files. So like the drawing behind me was like an airbrush painting done with an arm based on, scripting about like a hair on a body, like fur for an animal or something. So I didn't get as deep as I would have loved to on that, because I think if I had been in more advanced robotic application classes, or if I'd done my thesis on that, which is a huge missed opportunity still in my mind, it would have led me quicker to this type of work that I'm working on now, which is still issues of of tolerance and accuracy, which is like when you want a machine to do something, how close is it, how far apart is it from the digital file and the physical world. So I would have loved to get more into that, but as it stood, I focused again on fabrication, and I did a thesis on kind of like a design build project in LA, which I learned a lot. Felt like I had to test the regular architectural bounds to see what my job would be. And then I went back to that firm and worked full time, and basically spent I would go to work and then I would stay up all night writing grants to work on digital manufacturing and fabrication type of research. So I started my own LLC, and I applied for a couple of NSF grants and received some starting funding to do, basically it's like pays for the proposal that you just put together, but doesn't pay for the full SBIR scope of work, because it was just me, which thank God never won one of those because I wouldn't have known what to do with it. So I just kept spending more and more time on this, and I would volunteer at the high school Fab Lab, which in Wyoming is like amazing that they have one, but there's just not really much vocabulary around what those tools are good for. Mm-hmm. So that all kept going until I was looking at the Pier 9 residency program and kind of formulating a proposal for what type of work I would do. And it was very much focused on just the same issue over and over again of like, how accurate is your fabrication? I didn't really have a sophisticated understanding of what the meaning of that study was yet. I just wanted to work on it more. And through that application process, I reconnected with a mentor from school. He was working at CW Keller and Associates, and he suggested that I basically reformat the research proposal to be more in line with what the fabrication challenges of Keller were, and that we apply for it, that I applied for it as an employee of Keller. So that was a great suggestion, and it worked out. So I got to dig into kind of the technological problems that Keller was focusing. We were looking at this application of aerospace manufacturing tools to complex form, or we were looking at kind of like tool path optimization work for 5-axis milling or robotic milling. So so then that led to the next phase.
Good. So because Keller was, I think that was who you were working with when I watched a video with Autodesk University just before this podcast, and you spoke very well about a particular project, Alliance Theatre renovation in Atlanta. Mm-hmm. Was that one of your first projects? And give us a little bit of a feel for how that project came about, because it was a fascinating video, but also the end product was simply stunning.
Yeah, Keller's work is pristine. It's amazing. They've really developed a lot of manufacturing or like very highly complex engineered fabrication work that just is so precise and so perfect looking, and then has a material sensibility to it that is just absolutely perfect. So the Alliance project was already on the books by the time I got there. They've been working on the engineering for a long time, because as is typical with a lot of fabrication work, they'd reached a partnership with the architect and anybody else involved, like the other subcontractors that would be kind of touching the system. And their first step is to rationalize the surfaces. So they spent months working very closely with Trahan Architects and like the acoustician who was designing the panel optimization. So they worked from kind of like a curvy form language to, is this porous? Is it solid? And then from there, you kind of chase it back to what are the structural and connection implications of that. So they had already developed all of this form language, and it was and then they had started to fabricate, and what they were finding is that, so this is complex double curvature, big sweeping balconies that has, a representation of a surface that is actually hundreds upon hundreds of half-inch like steam bent oak stringers that approximate this curve, and then the distance between the stringers is parametrically organized to allow for more or less porosity for sound absorption or reflection. So just really, really, really complex and like difficult to build type of forms. So what they were finding is that basically their analog templating methods were not working. So they would build the armature. So it's kind of like a steel beam holds a steel column, holds a box, holds a fin, and then will receive all these horizontal stringers. And any templating that they were doing was causing more, it wasn't working, and they weren't sure which part wasn't working because there was no real way to measure all of, there's no easy way to measure this type of curvature across multiple elements. So for example, they would need to, if they knew this, they got to the armature point and then they needed to know the layout for these stringer parts, they would print hundreds of small, like long skinny strips of paper with tick marks running down them. And those tick marks would indicate like an edge or a centerpiece of a stringer location. So they would tape it up against a vertical fin and then try to register those points, by transferring it manually with a pencil onto the fin. And then you would do that for the entire assembly as it sweeps across, and then take these, steam bent wood only has a certain workability period, so they would try to tack it on there. And basically they were finding that like errors in this templating were causing enough visual defect that it didn't look as perfect as the parametric patterning needed to be. And like the problems were as simple as, it's humid when you're doing steam bent wood assembly, and paper doesn't respond well to humidity, and it deforms and it stretches, and it was like, yeah. So and then they couldn't even move past that point to understand if their armature had some kind of inaccuracy that was causing some kind of form problem.
Yeah.
So when I came on, they had already acquired a 3D projector from one vendor that honestly just had like a terrible interface and terrible software. And we couldn't really, it wasn't really adaptive to use with the platforms that we were running. Like any type of curve export was just, it was just really low functionality. So by being at Pier 9, starting to just, I had these visions of like going to Pier 9 and being like immediately on the robot and like working on all this stuff, like having a laser connected to it. But I basically spent, the residency is traditionally 4 months long, and I basically spent like 4 months calling people within the Autodesk network. This is like the real beauty of that residency, is that you have people will respond to your technical questions even when you don't know really what you're circling around yet. So I spent months like asking people in robotics and in kind of like carbon fiber layup software platforms how these tools really worked and why they couldn't work together, and basically like through that kind of understood a little bit more about what we needed. And I approached a different vendor and we engaged in a better partnership to get a better projector. And then we got this whole suite of software platforms and kind of tools and support. And so then we were able to start using a different, long story short, we got a better projector and we could actually project what we wanted on the forms.
Yeah, because if anybody's, I'm going to put the link of, I think it's on your LinkedIn, I'm going to put the link to it on the talk, and it gives you loads of visuals as well. So it's fascinating. So, but what are the challenges? I mean, obviously the Alliance Theatre were bought in right away. So they've given you the go ahead to be able to do all this research and the robotics. What are the challenges then for getting the guys on site to be able to deliver this as technical as you say it is, and as digitally sound as it is? Surely the challenges then on site are just incredible, and it's a constant battle. How important are those relationships and selecting the right contractor or subcontractor?
It's the future of digital fabrication and complex architecture, is to align either digital literacy or willingness to try new things and kind of technology trust in your subcontractor agreements and tree structure. Because so we had, when we look at like the prefabrication phase of this project, we had this really amazing situation where like the projector is incredibly accurate. So if anything that it is projecting upon is not in the right physical location, it won't show the right information, or it'll kind of glitch and say like no surface to project on. So we worked closely with our with the Keller shop staff and job captains to kind of, if the projector wasn't showing the right thing, the first answer is, well, the projector is wrong, because like I can't tell why it wouldn't show this, so I'm just going to discount the information. And so we had to kind of go back to the drawing board and say, it might be that the physical surface that we're trying to do this already is not accurate. So we went through this exercise of laser verifying every single component. So like the physical column that receives the big structural boxes, that then receives the fins, and then would receive the stringer. So we kind of did an iterative verification process to get everything more accurate, so that then you could project on the right surface. Like, because these are, a 3D projector does not just project a line that will be visible farther away. If you're, it projects a 3D line with 2 lasers. So if you're trying to project on your hand, and your hand is 1 inch behind, the line just won't show up. It will only show up when there's a surface in the exact right 3D position according to the calibration of the projector. So there was a great like light bulb moment where everything was better, perfect, had been iteratively verified, and then one of the engineers kind of like took one of the vertical fins and just like pushed it to the side. I think there's a picture of it in the projector, and all of a sudden it snapped, and like the fin itself snapped into the right location, and all the tick marks showed up on the edge. And so that was the first lesson, or the first like communication that worked to show all of the like amazing craftsmen in the shop that like what the cause of error was and how to work around it, and not just discount the digitally precise tools, because we really were relying on it at that point. So that was a huge victory, and it created a lot more trust. And then from there, we were able to take that same kind of mentality, and we developed a strategy around how are we going to like templating on a huge job site is full of tons of errors, and you're working off of like manual measurements, physical data. And what we needed to work off of was like something that was precise to the LiDAR scan. So from that, we kind of learned how to abstract like what were the edges that we needed to project on the floor or the wall for the starting points of these columns, and then these panels. And then we had our installers kind of communicating the logic to the GC and other team members. So it was really exciting to see that.
Yeah, I can imagine. And is it finished? Is that project completely?
I think operational? So. I've seen pictures of it open, and I think like the team that worked really hard on it at Keller is
there with their thumbs up.
Yeah. I mean, that's a huge success for that team. They did so amazing. I also think that they haven't gotten to, I don't know if they've all gotten to go see it and really be in the space with all of the panels. I think some of them got to be there for installation, but not for the finished product, which is
they should be there for the opening ceremony or the first show on the theater. Yeah. Surely.
I would love. Yeah, I think so too.
Okay, good. The invitation's probably in the post. So brilliant. Okay, so digital coordination, digital modeling, 3D scanning. Where is the future of this? Is it only going to be embraced in certain sectors, certain industries of construction, or do you see it sweeping across all?
It's an interesting time to ask that question, because what we're seeing now in construction technology is like this instant flip to like GCs relying on construction technology, like the construction technology market, and demanding a lot more of it. 6 months ago, everybody was like, I'm pretty sure we can get away without this digital precision, or without remote monitoring, or without construction robotics, any of the things that like allow you to have remote either data or like spatial understanding. So now all those platforms are highly valued, and as they should be, because I think there's just a big industrial or cross-industry mismatch between like people who understand robotics understand the need for precision, right? But they don't understand the constraints of construction. And then construction wants robots, but they don't really understand what the minimal viable conditions are to derive value from that. So I think what we're seeing right now is a big push, even on the entry level kind of construction technology things, products like video, or like remote video documentation, or worker tracking type of chips, and any kind of like automated robotic capture stuff. I'm really excited that the industry's getting a push in the right direction. I think that there's a huge burden to entry for more precise construction. It's a very well-established industry. There's a lot of protocol and tradition and actual like contractual legal standards that are really hard to change. I think where the problem lies right now is getting a better handle on, right now it's scan verification, because scanning is the only way that we can assess, that we can compare our model to the physical world. And there is no time built into the traditional schedule structure for this type of work. So everybody who's doing, like we were talking before about companies that do or do not invest in pre-construction engineering. Pre-construction engineering from the VDC standpoint or from like the robotics standpoint is really different from pre-con in actual construction. So I just think that like that area of problem solving needs a lot more space. And I think now that it's more of a priority that you need to have more remote digital precision data on your job site, maybe there will be more space for that moving forward.
And it's like we all know general contractors, their margins aren't as big as a lot of subcontractors, a lot of other people in construction. So they're seeing it, where's my return on investment here? Is this going to be an overhead? Is this something I can build a client for? Where's my return on my money? So I think, listen, we talked about it before, there are general contractors out there that are investing heavily, but they're also reaping the rewards of securing the projects, so getting the technology and being able to market from that, but also being able to tie in with the best, most innovative architects and the clients that are looking for this as well. But where do we see it moving from here? What's going to be the first one that they say, and you touched on quite a lot of them there, the first, we definitely need that. And I think COVID-19 will accelerate that. Will it be robotics? Will it be 3D lasers? Will it be drones? Will it be the video on site? What do you think is going to be the main one?
I think that a lot of those ones that you just listed are already on job sites in piecemeal configurations based on an innovation manager at a GC connecting with the right product manager at a technology company, and establishing those relationships. So like there's been a lot of effort on this in the marketplace within certain markets. I think that whether it's a pre-con consultant or a VDC firm or somebody at a GC that needs to own the pre-construction phasing and risk, when those people buy fully into the fact that more detail actually can reduce your risk instead of increase your risk. Because right now, with the current contract and liability structure, nobody wants to own the detail, the precision and like the data that will show that there's a problem. Because if you own that, then you need to solve it. I think once we can more regularly show like how many millions of dollars this type of precision can save if you just manage it correctly, and if you give it time, you need to give your team time to process it and bring it in and analyze the data for what you need out of it, then we can change basically the culture around risk and precision. And then we can start to move into a different model where it isn't just the GC refusing certain accuracy because they don't want to own the liability, and it isn't the architect just saying like, well, we told you what to do. I think there's just like a middle ground to be developed.
Yeah, and you're going to fill that.
Yeah, and I have to say, I mean, construction robotics are the best. That is because that is the first time that you put something on a job site that needs the precision of the model and physical verification from a scan and multiple types of localizing on the job site. And anybody working in that space with a pre-con or construction mindset understands that whole constellation of like colliding worlds. And so out of just sheer loyalty, that is the place that it's the problem's gonna get solved by cross collaboration.
Good. Now, if there's someone, because we get a lot of like interns, graduates listening to this, if there is someone that turns around and goes, you know what, Noni's 100% right, I am passionate about this, how would you recommend they get into your world?
This is another issue that's really dear to my heart, because from traditional architecture, I could not see, before I came to Keller, I didn't believe that there was like a fabrication job to be had. So first off, knowing that there's this really rich network of specialty fabricators all across the country. You have CW Keller, Cornerstone, Concrete Works, Chrysler and Associates, many, many others that you can start to look up and reach out to them and kind of understand what their engineering network is. Additionally, then you can start to see really progressive architectural firms that have computational design departments. They're also thinking about how their parametric models actually lend themselves to fabrication and construction. And then there are the construction automation programs are popping up in the United States. I mean, Stanford has a really exceptional industrialized construction program that really focuses on this. So kind of just doing, again, you just have to do like a bunch of internet digging and reach out to people, especially right now. Everybody's available. Everybody from this world is really helpful because they had to figure it out themselves in order to get into this small field. And I would just be bold and reach out and ask questions.
Good. And if they were to reach out to you, where's the best place to get you?
I think LinkedIn is the right format.
Excellent, no problem. Good. Now, just before we go, I wanted you to make a couple of bold statements. What's the future of your word look like? And I want you to take not your current work or give away any secrets or the secret sauce, but give us an idea from a general contracting pre-construction point of view. What do they need to absorb? What do they need to change?
My world is currently, quote, forever focused on automated layout. That could be for a floor plan layout. It could be for pinpointing a certain location in physical space that's driven from the model. That is where like the connection of a robot to the 3D projector at Autodesk worked on. That is what I was working on at WeWork, where I was working between the reality capture team and the field and robotics vendors. It's a steady course that keeps guiding me, no matter what particular project I'm working on or what company. When we can do automated layout, so that's like taking a drawing from the model, doing whatever you need to do to coordinate it with a scan in the physical site, and then driving like a mobile total station, basically. The robot is almost irrelevant to the fact that you need to do the robot doesn't matter until you do all of the coordination around the actual like physical information and digital planning. So this is mixed up in a messy answer, but like automated layout
Good.
is the feature.
And you're talking about the digital planning there before you get to bring the robot on board. That's where that's your specialism. You get the digital side 100%, then you bring in the robot, and then it becomes a physical.
Yeah, even if you can't perfectly coordinate it and you don't have 100% resolution or understanding of where if your model is updated to the scan, for example, understanding where it's not perfect or to what degree you cannot trust the positioning of the robot based off of the model is also very important, because when you understand that, you can still get a lot of value out of automated positioning systems. You just need to, there's like a contingency factor of like, how inaccurate is this? And then what is our risk based on that understanding? So any efforts in this area are really, really important, and they really just help to enrich the understanding of what coordination can do.
Yeah, very good. And I'm interested with WeWork, how difficult was it, or how much did they embrace what you were doing, and how easy was it convincing not only them, but also the subcontractors? But you got to remember, WeWork have done projects all over the world. Was it embraced everywhere, or did you work on a specific US wide?
Well, I went to WeWork because they had a concentrated team of roboticists and construction technology specialists focusing on this type of issue. And so you had a really supportive network of people that could help you solve problems and help push things forward, and then get kind of internal buy-in. The way that we internally executed some of these strategies was that we had an internal GC. So that was WeWork Construction was within the company. So as a construction technology specialist inside, you could kind of say, I'm going to solve this problem for you on this one job. If it goes very well, we will start to scale it up a little bit, and I'll learn more about like how it is or is not working. And that was kind of also the approach that we took with our robotic startup and hardware vendors, where we would say, okay, we have a little bit of control over what our situation is. We want to apply a new solution, and we're going to measure it. We're going to try it again. And then we would make a prospective scale plan. So it was very, very supportive. But I think when you get into, the beauty and the downfall of WeWork was the scale at which they were growing. Change and process improvement in that situation is pretty unwieldy. It is really hard to get enough planning done for a highly technical solution in order to execute it successfully. That said, one of the best parts of my job there was working with the field team and building consensus and aligning our understandings of like what the challenge was and what the value of a new solution would be. And I really, really enjoyed that part.
Fantastic. Now, Noni, this has been an absolute pleasure. Something different for our network or our audience. Traditionally, we would look at pre-construction and estimating within general contractors, architects, owners, developers. But this gives us another perspective. So thank you very much.
Thank you. It was great.